Mark 10 or more points on each of the scatter graphs below to show an example of the type of correlation named under each graph. So we want strong positive correlation in the first one, strong negative correlation in the second one, and no correlation in the last one. So here we see strong positive correlation. It's strong because the dots are all close together. So if we were to imagine a line of best fit, a line going right the way through these, the dots are quite close to that line. And it's positive because it's going uphill. And the second one, we have strong negative correlation. Again, it's strong because the dots are all close together. They are forming a line, or they're almost forming a line. And it's negative because it's going downhill. If the question asked for moderate correlation, the dots would be further apart. And if it asked for weak correlation, they would be even further apart, but they would still be forming a line. In the last question, we're asked for no correlation, which means that the dots are completely random and there is no line that can be drawn in. There is no line of best fit. The dots are not forming a line upwards or downwards. A few days before the Scottish independence referendum in September 2014, a YouGov poll estimated the support for the No campaign to be 54%. Part 1. If YouGov sampled 1,000 people, find the margin of error. Write your answer as a percentage correct to one decimal place. Part 2. Create a 95% confidence interval for the level of support for the No campaign in the population. Okay, so if YouGov sampled 1,000 people, find the margin of error. Write your answer as a percentage correct to one decimal place. So the formula for margin of error is 1 over root n, and this is not given in the formula book. You have to learn it off by heart, where n stands for the number in the population, the number of people. We know that the sampled number of people was 1,000, so it's going to be 1 over the square root of 1,000, which gives us 0.03162 as a decimal. We want it as a percentage, so we multiply this number by 100, and we want it to one decimal place, so we get 3.2%. So the margin of error is 3.2%. Part 2, create a 95% confidence interval for the level of support for the No campaign in the population. So that's going to be p hat plus or minus 1 over root n, which is the margin of error. So p hat is our percentage, our 54%, which was given in the question. And we add and subtract our margin of error, which was 3.2%. So it's going to be 54 plus or minus 3.2, which is going to be 50.8 if you're subtracting. So 54 minus 3.2 is 50.8. And if you're adding, it's going to be 57.2. So 54 plus 3.2 is 57.2. So we are 95% sure that the level of support for the No campaign is between 50.8% and 57.2%. So we cannot be sure, but we are 95% sure that it is between these two percentages.